class we will study about bipolar junction transistor. So in previous classes we have discussed about diodes, application of diode, okay. Then we have also studied about Zener diode, okay. So this we all have studied in unit 1 about the diodes, okay, various applications of diodes and Zener diode as a regulator, okay. Now in this class we will study about bipolar junction transistor. So first of all we have to study why it is known as bipolar. This is bipolar junction transistor, okay. Why it is known as bipolar, okay. So it is bipolar, okay. So bipolar, it is due to the fact that the charge carriers are both electrons and holes. So in BJT, in bipolar junction transistor, the charge carriers are both electrons and holes. So it is known as a bipolar device, okay, bipolar device. How we can define a BJT? So a BJT, it is a bipolar device which consists of, it may be either NPN or PNP. See, this is N, P, N, or it may be PNP. P and P. Okay. So there are two types of BJT transistor. First one is NPN and the second one is PNP. So a BJT, it consists of two PN junction diodes. It consists of two PN junctions. See, N, P and N. So it consists of two PN junctions. First PN junction is NP and it is like this. So it consists of two PN junctions in which the center part is sandwiched between two opposite type of semiconductor. So we can see in NPN or PNP, here P-type semiconductor, this is N-type semiconductor, this is P-type semiconductor, N-type semiconductor. So NPN transistor and this is PNP transistor. Okay. So in NPN transistor, P-type semiconductor material is sandwiched between two N-type semiconductor materials, whereas in case of PNP transistor, N-type semiconductor material is sandwiched between two P-type semiconductor materials. Okay. So here we can say that it is a three terminal bipolar device. Why three terminal? First terminal is this N type, second terminal is P type and the third terminal is N type. Here in case of PNP transistor, first terminal is P type, second terminal is N type, third terminal is P type. Okay, and it is bipolar. Bipolar means the carriers in NPN or PNP transistors, it is because of both holes and electrons. So current conduction can take place due to holes and electrons both. That is why it is known as a bipolar device. Okay. In case of BJT, the three terminals, suppose in case of NPN transistor, this is N, P, N, and this is P and P transistor. Okay, the three terminals are emitter, base, and collector. This is emitter, base, and collector. So E stands for emitter, B stands for base, and C stands for collector. Okay, E stands for emitter, B stands for base, and C stands for collector. So in case of NPN transistor, emitter terminal is N type, base terminal is P type, and collector terminal is again N type. Whereas in case of PNP transistor, emitter terminal is P type, base terminal is N type, and collector terminal is P type. Okay, symbol of bipolar BJT. Okay, so NPN transistor, it is like this, NPN. So what is the symbol of NPN transistor? This is emitter terminal, this is base terminal, and this is collector terminal. Okay, so we can represent like this. This is collector terminal, this is base terminal, and this is emitter terminal. Okay, and this is emitter current, this is base current, and this is collector current. This is IC, collector current. Similarly, for PNP transistor, this is P and P. How we can represent it? By using symbol. This is emitter, base, and collector. This is emitter terminal, this is base terminal, and this is collector terminal. So the direction of emitter current, it is like this. Base current, the direction is like this, and the collector current, the direction is like IC. Okay. So this is the direction of emitter current, base current, collector current. Okay, and this is the direction of emitter current, base current, and collector current. So it is a three-terminal device. BJT, it is a three-terminal device. The terminals are emitter, base, collector. Emitter, base, collector. This is NPN transistor, and this is PNP transistor. Okay. So NPN transistor, this is PNP transistor. So this is the symbol for NPN transistor, symbol for PNP transistor, and this is the direction of current, that is emitter current, base current, and collector current, like this. Okay. Then we will study about the operation of BJT. So in case of BJT, there are three terminals. That is emitter, base, and collector. Okay. So suppose this is emitter and base and collector. Okay. So base is common. Base is in between emitter and collector. Okay. So we can determine the operation of BJT by using biasing voltage. So in first case emitter base junction and second case collector base junction. Okay, so these are the two types of junctions, emitter base junction and collector base junction, and we have to biasing. Okay, so if emitter base junction is forward bias and if collector base junction is reverse bias, then the mode of operation of this BJT transistor, it will be in active region. Okay, biasing means we are connecting some external voltage to emitter base junction and some external voltage to collector base junction. Okay, so if by connecting external bias voltage, if emitter base junction if it is forward bias and if collector base junction if it is reverse bias, then the mode of operation of this transistor it is in active region. Similarly, if this is forward biased and again if this is forward biased, then it is and the next one is if it is reverse bias. If it is reverse bias, then it will be in cutoff mode and saturation, cutoff region and saturation region. Okay, so basically we will study about these types of configuration. Okay, so emitter base and collector base. If the emitter base junction is forward biased and collector base junction is reverse biased, then the transistor it will operate in active mode or in active region. If the emitter base junction is connected in forward bias and again collector base junction is connected in again forward bias, then the mode of operation it is in saturation mode. And if emitter base junction is connected in reverse bias mode and collector base junction is connected in reverse bias mode, then it is in cutoff region. So basically a transistor is used for amplification. Okay, so a BJT transistor is generally used in amplifying device, in amplifying for amplification purpose. Okay, so it is generally used for making an amplifier circuit. Okay, so an amplifier circuit for amplification, the transistor has to operate in the active region, and saturation region means here it is cutoff. Cutoff means it is represented as open switch. Saturation means closed switch. Okay, so generally we are operating BJT in active region of operation. Generally BJT it is made to operate in the active region of operation for amplification purpose. Okay, so suppose this is NPN transistor, this is base terminal, this is emitter terminal and this is collector terminal. Okay, so this is forward biased, so it is N, P and N. So how it is forward biased? Like this, external bias. This is external bias voltage and this is reverse bias. This is emitter base junction and this is collector base junction. There are two types of junctions. This is the terminals are emitter, base and collector. Okay, three terminals and two junctions. First junction is emitter base junction, second junction is collector base junction. This is common base configuration of BJT. In common base configuration of BJT, emitter base junction is forward biased. Normally it is forward biased, and this collector base junction is reverse biased. So now we can say that this transistor, it is operating in active mode or active region. Okay. Then we will study about the types of configuration, BJT configuration. First type is common base configuration. Second one is common emitter configuration, and the third one is common collector configuration. In case of common base configuration, the base terminal is here. The base terminal is common to both input and output. Okay. Here emitter terminal is common to both input and output, and here collector terminal is common to both input and output. Okay. Now this is about the types of BJT configuration. Now in case of BJT, suppose this is N, P and N, it is emitter, base and collector. Okay. In case of BJT, okay, emitter terminal is heavily doped. Okay, and this base terminal is lightly doped, and the collector terminal is in between emitter and base in terms of doping. So it is moderately doped. Okay. So we can say that emitter terminal, it is heavily doped. It is this terminal, base terminal is lightly doped, and it is in between emitter and base in terms of doping, and it is very thin. This base terminal, it is very thin, whereas collector terminal, its width is more than emitter terminal. Common base configuration. Okay. Suppose this is N type, P type, again N type. This terminal is emitter terminal, this is base terminal, and this is collector terminal. Okay. So if it is connected like this, negative and positive, and if this is connected like this, positive, negative. Okay, so if it is VEE and if it is VCC. Okay, so these are the two external biasing voltages. Okay, so this emitter base junction, if it is forward biased and it is reverse biased. Okay, so this is the case for then the transistor. It is in active mode of operation. Now the transistor, it is in active mode of operation. Okay, when the emitter base junction, if it is forward biased, and if this collector base junction, if it is reverse biased, then this mode of operation is active mode of operation. Now in active mode of operation, since this is forward biased, this emitter base junction is forward biased, so here the majority carriers in case of N type, the majority carriers are electrons. So electrons will move towards, if this electron, it will move towards the base terminal. Okay, and this is very lightly doped and also it is very thin. Okay, so here this electron, it will reach here, and some electrons will combine with the holes that are present in the p type. Okay, but since it is very lightly doped and it is very thin, so only some of the electrons will combine with the holes carrier that are present in the base terminal. Then the remaining electron, it will move in the collector region. So in this way we can say that emitter current, it is equal to base current plus collector current. Okay, so here only 5% of the electrons will recombine with the holes in the base region. So the base current, it is very small, only contribution is 5%. Here it is 95%. So 95% of the electrons will move from this region, from emitter to collector. Okay, it is very heavily doped. Because of this heavily doped and because many electrons, many charge carriers, that is the majority carriers, it will move towards the base region. But here it is lightly doped and it is very thin. So the carriers in the base region, that are the holes, some of the holes may recombine with the electrons. Okay, and the remaining electrons that are not recombined with the holes, it will reach in the collector region. Okay, so in this way movement of carriers takes place in case of BJT transistor. Okay, now we can see that the emitter current, suppose the symbol for this is like this. Here it is emitter, base current IB, here it is IB, and this is IC. It is like this, negative, positive, and here it is positive, negative. This is VEE and this potential is VCC. Okay. Now this is NPN transistor. Okay. Now we can say that emitter current, it is equal to base current plus collector current. Emitter current, it is equal to base current plus collector current. So base current constitutes a very small amount in the overall current. So IB is very small, Okay. Why IB is very small? Because the base junction, this base terminal, it is very lightly doped and it is very thin. So here very less number of holes are combining with the electrons. So the base current is very less, okay, and the remaining electrons, it moves towards the collector terminal. So IE, it is equal to IB plus IC. So we have studied that in case of common base configuration, emitter base, it is forward biased and collector base junction is reverse biased. Okay, emitter base junction is forward biased and collector base junction is reverse biased. So forward bias means very less resistance and reverse bias means very high resistance. Okay, so a BJT transistor in common base configuration, and if it is connected like this, emitter base, if it is connected in forward bias configuration and collector base is connected in reverse bias configuration, then it will provide low resistance path. It will provide low resistance path in the input side and very high resistance path in the output terminal. Okay, so in the output we will be getting a high value of output voltage. Why high value of output voltage? Because of the presence of very high resistance in the output in the common base configuration. Okay, and emitter base junction, it is forward biased. So all the carriers, it will move from emitter towards base. Okay, and in the base terminal, some of the electrons, it will combine with the holes present in the base, and the remaining, it will go to the collector terminal. Okay, and in the collector terminal, because of the presence of very high resistance, we will be getting high value of output voltage. So in this way, a BJT transistor can be used for amplification. Okay, so we can see now, we can see that this is the circuit diagram of NPN transistor. See, this is N, this is P, and this is P, and this is again N. NPN transistor in common base configuration. The base terminal here, the base terminal, this is the base terminal. Base terminal is common to both input and it is common to output also. That is why it is known as common base configuration. So in common base configuration, if this is forward biased and if this is reverse biased, okay, then if any signal is applied in the input side, then it will be amplified. This voltage, it will be the output will be amplified. Why output is amplified? See, in case of forward bias, the input resistance is very low, and due to reverse bias, the output resistance it is very high. Because of this nature, it amplifies the signal. Okay. Now we will see this IE can be written as IT plus IC. Okay. Now in case of common base configuration, we can define current amplification factor How we can define the current amplification factor? It is also written as alpha. In case of common base configuration, current amplification factor, it is defined as the output current. Output current is IC to the input current. Input current is IE. That is, here the current amplification factor in case of common base configuration, it is output current divided by input current IE. Okay. Now we know that IC is always less than IE, because see IC by seeing this equation, suppose this is equation A. Okay. So from this equation we can say that IC is always less than IE. So value of alpha, it is always less than unity. Okay. Now the practical value of alpha, it lies between 0.9 to 0.99. Okay, and we can increase the value of alpha. How we can increase the value of alpha? How we can increase this alpha? By decreasing IB. If we are decreasing IB, then IC will increase. How we can decrease IB? We can decrease IB by, if it is lightly doped, if we are doping it very lightly, and if the thickness of the base region, is very small, and if it is very lightly doped, then in that case IB will be small. If IB is small, then IC will be more, because IE is equal to IB plus IC. So in that case alpha can be increased. Okay, you got it? See, first of all we have to decrease IB. How we can decrease IB? IB can be decreased by decreasing this thickness and doping it very lightly. Then IB can be decreased. So if IB is decreased, then alpha it will be increased. How alpha will be increased? Then in that case IC will be increased. So in this way we can increase the value of amplification factor, and practical value of amplification factor in case of common base configuration, it is from 0.9 to 0.99. Okay, then we will study about the relationship between input and output current. See, in case of common base configuration, IC it is equal to alpha IE. It is equal to alpha IE. Okay. Now this is due to majority carriers. Okay. see, I is IE current and alpha IE. Alpha times IE is the current that is available across the collector terminal due to majority carriers. Okay. Now, if we will consider the leakage current also, then it will be I leakage. So this leakage current, it is due to reverse bias of collector base junction. You can see here, if the collector base junction, if it is reverse bias, then a reverse leakage current will flow due to minority carriers, and if it is represented by this ICBO, so ICBO is I leakage current, okay. So ICBO, it is the reverse leakage current between collector and base when emitter terminal is open, that is when IE is equal to 0. This is the reverse leakage current between collector and base terminal. So we can write like this. IC, it is equal to alpha IE plus ICBO. This is the reverse leakage current. Okay. Now it is equal to IC. So it can be written as IE, it is equal to IB plus IC, then it is ICBO. Okay. Now IC into 1 minus alpha, it is equal to alpha IB plus ICBO. Now we can write IC, it is equal to alpha divided by 1 minus alpha IB plus ICBO divided by 1 minus alpha. So in this way we can determine the relationship between IC, IB and ICBO. Okay. So the collector current in case of common base, suppose this is base, emitter and collector. In case of common base configuration, the collector current, it is due to the majority carriers as well as minority carriers. So due to majority carriers it is alpha IE, and due to leakage or minority carriers it is I leakage. So I leakage, it is represented by ICBO. So what is ICBO? ICBO is the current flow between, it is the reverse current that is flowing between collector and base when this emitter is open. So if emitter terminal is open, then in that case IE is also equal to 0. So in this way we can write down the expression for IC. Okay.